Good evening, all of you, and welcome in this session. This is the seventh session of this tutorial series of 2023. Today, in this session, we will cover Symbolic Mathematics Toolbox, which is very important to understand, to use. First of all, I would like to wait some more participants so that they can join us and we can start at right time. And I hope very soon all the participants will be with us. Okay. Good evening, all of you once again. So this session is very important for all of you because in this session we are going to cover Symbolic Math Toolbox. Okay, so why the Symbolic Math Toolbox is important? We will discuss all these things, how we can create symbolic variables. Okay, Seni, Saleh and Olubase, good evening and welcome in this session once again. So this toolbox is very, very important to all of you while you are thinking for scientific computing, you want to solve engineering problems, you want to solve mathematical problems which are associated with the optimization techniques, numerical methods, okay, machine learning, sometimes deep learning, and along with the if you have mathematical modeling. Okay, so there are many problems which depends upon symbolic mathematics because we need the answer, exact answer. So in that case, we need to define symbolic variables. Okay, so first I would like to share my desktop. So this is the topic for the today, Symbolic Math Toolbox, which is getting started. We need several lectures on this topic because in a single lecture, we are not able to cover all these things. But I think within 3 or 4 sessions, we will cover all these things. But today's session is important due to all the fundamentals which are required for our discussion will be covered in this session. And I hope you will enjoy today's lecture. So this is the main agenda which we are going to cover in the present session, Symbolic Math Toolbox, product description, what is Symbolic Math Toolbox, okay, provided by the Matlab. Then create symbolic numbers, variables, expressions, all these we will cover. And third most important is create symbolic variables, how we can create symbolic variables in Matlab. Then symbolic expressions, how we can reuse names of a symbolic object which we defined in the Matlab. And at the end, we will discuss about create symbolic functions. Okay, how when we have symbolic variable, then along with how we can create symbolic functions. And then I will try to present some few examples how we can use these symbolic functions. Okay, and whenever we are able to cover all this content, then these will be very helpful. So symbolic, to perform symbolic math computation, we need symbolic method toolbox which provides functions for solving, plotting and manipulating symbolic math equations, and we can create, run and share symbolic math code using Matlab live editor. The toolbox provides functions in common mathematical areas such as calculus, linear algebra, algebraic and ordinary differential equations, equation simplification, and equation manipulations. So that's why we need a symbolic math toolbox. Okay, and there are some features which are described as below. You can see here. First one is symbolic integration, differentiation, transforms, and linear algebra. And by using the toolbox, we can do algebraic and ordinary differential equations. Also, this provides solvers, which we will cover in the coming sessions, and simplifications and manipulations of symbolic expressions. Sometimes we have different type of equations which are involving some parameters. So when we solve these equations like a differential equation, when we want to solve, and the solution which we obtained will contain some variable along with some parameters. So this toolbox will help us for this type of problems. A unit system for specifying, converting, and computing using SI or US and custom unit system also we can do. Second last, we have plotting of analytical functions in 2D and 3D. There are many problems when we need a function in the form of symbolic variables, and we can plot them in 2D or 3D. And the last one, we have symbolic expression conversion to the Matlab, Simulink, Simscape, C, Fortran, LaTeX code, etc. All these we can do by using this symbolic toolbox. There are huge applications and use we will discuss in the coming sessions, and many problems we will cover. So the thing is how we can create. Just 1 minute, I have to. Yes. Okay. So sometimes, as you can see, we can create symbolic numbers by using sim function. This function will be used for the symbolic number. And symbolic numbers are the exact representations of the number as we have. And unlike floating point numbers are not the exact. To create a symbolic number by using sim or to compare, okay, we will use this sim function, and we can compare with the floating point number. Okay, see here, these are the Matlab code. Okay, note this point. If you will use sim function for the number, and this is the 1/3. Okay, I will do all these experiment in the Matlab also, so that you can understand all these symbolic numbers, symbolic variable, and this will help you in many ways. So here also you can see in the Matlab. Yes, I am using here. Sim, and here is 1/3. Okay, then I will enter. See, I have the same number and 1/3, which is the exact at this place. If you will enter 1/3, okay, this will return the value in the form of a floating, and this value is not the exact value. So sometimes when we are solving some problems and we need the exact value, so in that case we need the outputs which are the exact solution. In that case we are using sim for numbers, and this is the expression which we can use for the same. Okay, and along with if you have any questions related to the content which we are discussing today, you can put your questions in the chat box, and I will try to justify your questions. Uh, I will not run this lecture. Uh, you need to stay connected with me, and I will try to explain each and every point so that you can see the difference between this each concept. Okay, so here you can see once again sim square root 29. See here one more example. If I am using here square root sqrt is a inbuilt function in the MATLAB, and when I will enter 29, okay, and this will return the value of a square root. As we know that this is not the perfect square, so the value of this square root will be in the form of floating. Okay, so if I am using here for the square root same, then I have square root of 29. Okay, square root of 29. See, this will return the exact value. Yes, and you can see here is 29 raised to power 1 by 2, which is the exact. And if you are using here petty function, okay, petty function for ANS, and ANS, the value which we got at this place is used at this place. Okay, and I'm using here petty function, and see what happened. Yes, so it is returning the same as we have the input at this place. Okay, and if you are using again the sim for the I have at this place is 25. Okay, and when I will enter, it is returning 5 because 25 is perfect square of 5, and that's why square root of 25 will be 5, and this is the exact value. But in the case of the previous example which I presented here, 29, and as we know 29 is not a perfect square. Okay, so it is returning the value in the form of this one, and this is the exact value. So in this way we can use sim for numbers. Okay, and once again I am asking you, you can put your questions in the chat box, and I will cover all your questions and I will justify you. So the symbolic numbers is represented in the exact rational form. Okay, and while the floating number is decimal approximation. Okay, decimal numbers or the floating numbers are not the exact value. So the symbolic result is not indented, while the standard MATLAB result is indented, as you know. Okay, so this is the use of sim for numbers. So here we have the calculation of a symbolic number. We can use for the calculations also is, you can see here is sine and sim pi. So when we will use sim pi, as you can see here, this will return the exact value. Okay, while when you will use in this way without using the symbolic variable, symbolic number, then we need to see the experiment in the MATLAB. It will be better. Yes. So here I am using sine function. Then I have sim pi. Okay. This is the pi, and when I will enter, so the answer you can see we have the exact, we know that the value of sine pi is 0. While if we are using in this way sine and pi, this will not return the exact value. Okay, so this is the value in the form of floating. Okay, so this is the difference between the use while calculating the values of sign or other calculations also. Also, by using a symbolic variable, there are two functions, two notations, which you need to understand here. Either we can use sims or sim. Okay, and it is very typical to sometimes which one is useful. Okay, so I will justify you by giving more examples, and this will help you. Okay, in the very first case, this will when we will use a sim function only, this will create numbered symbolic variables, or create symbolic variable in MATLAB function we can do. And when we are using sims, this function, this will create fresh symbolic variable for interactive symbolic workflow, and that's for the symbolic variable creation at the MATLAB command line or MATLAB live script. A fresh symbolic variable does not have any assumption. Okay, so here you can see the example. So this expression, by using this expression sims x, we can easily declare the variable. Sometimes when we have the script file or the long program, okay, in the beginning you don't know which variable you need, but while you are writing your program and in between you need new variable. Okay, in that case this will help you in many ways. But in the second case is you can see here, this is also the way to declare the variable. But when we are going to start to write a program in the beginning, and if we are familiar that we need these variables for the programming, then we can use this one. Okay, and the first command create a symbolic variable in the MATLAB workspace with the value x assigned to the variable, and the second creates the symbolic variable y with the value y. Okay, so this is the difference you need to understand, because here we are using equal to sign. Okay, so this value will be assigned to the variable y. See, note this point very carefully. What I am saying, when as you know, this equal sign we are using for the assignment. Okay, and here we have the symbolic variable by using sim, and this variable is assigned at this place. Okay, sometimes if you want to use at this place x, then what is the meaning of this equation now? If you are using like in this way, x is equal to same, sorry, x is equal to, if you are using like in this way, x is equal to same y. Okay, so the meaning of this one is when you will enter x, y will appear. Okay, because this information is stored in x variable. Okay, but here this is the this code we can use in the symbolic interactive symbolic workflow, and is the symbolic variable created at the MATLAB command line or in MATLAB live script. Okay, see here, I want to present here some examples. Just 1 minute. Okay. Dennis and Canada Solar, good day, all of you. Dennis, you are asking about the presentation. Yes, sure. If you need this presentation, I will provide you. Okay, no problem. See here. See here. Uh, we are using. We are using here Sims function, and by using this Sims function, we can create multiple variables in one command. Okay, as you can see here, we are using Sims, and here is A and B and C. Okay, if you want to introduce more variables, you can do. But in the case of this one, we can declare one variable at one time by using this statement. Okay, by using this one. If you need one more variable, then you will use sim and x. Okay, in this way. See in the MATLAB and how we can use all these expressions. Yes, I'm using here CLC. See in the MATLAB, CLC. I'm using here Sims. Okay, and I have x variable, then I have y and z. Okay, first of all, I would like to show you why we need symbolic variable. This is very important to know. I'm clearing the clear all because you can see on the workspace there are several variables are there. So I'm using here clear and CLC. So now if I want to assign a function f is equal to sine x, I have suppose this is a function x square plus y square, and when I will enter, see what happened. There is an error message. There is an error message because the MATLAB not recognize the variable x, and also it is not recognize the variable y. So that's why we have to declare the symbolic variables. Only then this function will work. See here, I am now declaring the variables by using Sims statement, and I have x and y. Okay, I have x and y, and now when I will enter and see, I am using the same above statement, f is equal to sine x square plus y square. Okay, and now when I will enter, see there is no error now. Now MATLAB understand the about what is x and what is y, and also when you have create function by using x and y, where x and y are symbolic variables. Now you can pass the values through this function. See if I have f and I want to pass the value 1, 2. The value of x is 1 and the value of y is 2. Okay, it is out of the right subscript. Okay, here is some error. CLC. Okay, just 1 minute. Yes, I have Sims x and y. Okay, and f is equal to, you can write a function sine x plus y. Okay, x plus y, then enter. If I pass the value 1, 2, out of range of subscript. Okay, out of okay, we will discuss this problem in the next level, CLC. Now, if we want to declare more variables by using the same, we can use a sims function or sim function. See how we can declare multiple variables by using sim. Okay. So we need to use these statement. First, we need to clear the workspace and create a row vector containing the symbolic variables A1, A2 up to A20. Okay, and assign it to the variable A. So the vector which we are going to create and the element are A1, A2 up to A20. Okay, and all these information are stored in the variable A. Then display the variable of the MATLAB in the workspace. See, so first we need to use clear all because there will be several variables. Okay, and as you know, clear is used to clear the variables. Then we will use, we want to store the variable which will be generated, several variables, and we are using sim function. Okay, as you can see in this statement, we are using sim function, and then see this variable here is A1, A2, A3 and so on up to A20. So this is the main variable and these are the index of the variable 1, 2, 3 up to 20. So when we will use this statement, this will generate 20 symbolic variables and all these symbolic variables will be saved in A. And all these will appear in the workspace. As you can see, these are the variables will be generated in this way. See in the MATLAB. So what we do here first, we are using here a script file. I am using here a script file. So this will help you. Control S. These are the sim variable. Okay. First, I need to save this file with some name, and the name of the file I am using here is sim variable. So this file will be saved in my current directory. Okay. So you can see here is my current directory. So first I need to use here clear. This command will clear all the variables. Either you can use only clear. Okay, clear and clear all both have same meaning. Then I want to save the information. A is equal to, I am using here sim. Okay, and then I have A and index of this will be 1 to 20. 1 space 20. Okay. And if you want to print, then again use here A. Okay. So see, when I will run this file, and this is very small code as you can see, when I will run this file, okay, you can see in the command window. You can see in the command window. Okay, so all the variables, symbolic variables A1, A2, A3 up to A20 are stored in A. Okay, so here A is a vector, variable, a symbolic variable in the form of symbolic variable, and its all the elements are in the form of symbolic. So in this way, we can easily generate By using the same statement, we can create a vector, we can generate array, we can generate a matrix also by using this type of operation. And you can see all the variables are symbolic variables. So by using sim statement, by using this sim statement, we can generate any number of vector, and all these elements will be symbolic variables, as you can see at this place. If you will change this number, okay, if you will change this number, I am using here 1 to 10. And again, when you will run this script file, we have now only, also you can use here CLC. Okay, we can use here CLC. So this will clear the command window also. Yes. Now we have only 10 numbers which are symbolic variables. Okay, these are 10 symbolic variables, A1, A2 up to A10, and 1 to 10 are the index. So here this is the variable and these are the index of the A. Okay, so in this way you can generate any number of variables. If you have any question, you can put in the chat box. Okay, network from my side is very fine. It may be from your side, Nidhi Monk. Okay, and happy to be part of this. Thank you, Abdul Wasio. Thank you to be part of this session. And I think this is your first time to join this live session. Okay. See, here is some more example. Yeah, this is also important to explain you. Here, who, when you will use who statement, this will return the variable A. And if you are using here whose, see, this is the information about the variable A, which is in the symbolic form, and you can see the first column is representing the name of the variable, and second is the size. There are 10 symbolic variables which are stored in A, and size of each one is 8, and class is symbolic. And also when you will double click on it, see, this will open. Okay, and yes, just 1 minute, I want to open this one. Yes, you can see the size of each one be 1 by 1, 1 by 1, and this also will be 1 by 1. So these are the element. Okay, and these are up to 10. Close it. And also you can get the information from the, you can see it from the workspace. So who command will return the values of all the symbolic variables or the variables which are stored at its place. Okay, and whose will provide us some more information about the variables. As you know, we have already discussed. Canada, I think from my side there is no network issue, because I am also attending this session, and this is me. You can see the message in the chat box. Hello everyone, I am replying in the chat box. Okay, everything is fine. Okay, so the thing is, I always to avoid all type of problems from my side, I am using two systems, so that from one side I am delivering my lecture, and also I am attending all the things are delivering properly to all of you. and I check that all the session is going very smoothly. Okay, so if someone have the problem, that may be from your side. If the problem will occur from my side, I will remove it. Okay, so thank you for the understanding. Yes. So here is A is returning the symbolic variable 1 to 20, and there are in the form of array or vector, and 20 symbolic variables are there. So by combining sim or sims, we can create many fresh symbolic variable with the corresponding variable name in the MATLAB workspace. Okay, so this is the use of sim and sims, and many times we will use these two functions in the coming sessions. Okay, just you need to understand, and if you have the question, don't worry, but the concept must be very clear when you will use and you will do practice on it. This will be very more understanding for you. Okay, see once again. Yes, here is we have the same statement, but the thing is by combining sim and sims, we can create many fresh symbolic variable with the corresponding variable in the MATLAB. And see here we are using the statement clear the workspace first, because it is very important. Sometimes when you are creating symbolic variable, and if there are already exist in the workspace, then this will be problem for you to use the symbolic variables. So it's very important to use the clear function for the workspace. Okay, so we can create a fresh symbolic variable by using a1, a2 up to a10. Okay, a is assigned the metal variable from this one respectively. So all these variables will be assigned to this one. So the process is very quite simple. First we will use here clear, and then we will use this statement sims, then this will generate an array. Okay, and in the previous example all these arrays was stored in where? In A, but here there is a sims. We are using both these two functions. Okay, so by using this function, as you know, in the very first example I put like sims x, y and z, we can use statement in this way. Okay, but all these are 10 variables we want to generate. So at this place what will be? All these like a1, a2, a3 up to a10. Okay, so this will generate these vectors in symbolic form, and but when you are using this one, so the meaning of this one or this one will be same. Either you can use in this way. Okay, so we can use this statement also. So and this will generate the 10 symbolic variables, and when we will use whose statement, this will display all these variables. Okay, so see in the MATLAB how this will work and how the values will return. See in the MATLAB. I am using here sims, and then close this one, close this statement. Okay, here is bracket. Here is bracket. Okay, so there are 10 variables, and where come again here, this is not required. When I will run this file, either you can use this statement in the command window, or you can use by using creating a script file. There is no difference. Okay, so here you can see when we run this code, okay, there is no returning value in the command window, but you can see the workspace. See in the workspace. Okay. So there is A1, A2, A3, A4, A5, A9 up to A10. So 10 variables has been, symbolic variables has been generated. Okay. And if you want to display this symbolic variable in command window, then we need to use whose command. Then we need to use whose command, and when I will enter, and this will return all the information about these symbolic variables. You can see here in the first column we have the name of the variable, in the second column we have the size of the variable, these are the bytes, and then we have class, attributes. Okay, so here in the first column you can see all the variables. Again, when I will run this code, yes, if I will use here A1 and then enter, so it is returning the same. Okay, we need now all these are symbolic variables, and you can use all these symbolic variables in many ways. Okay, so here suppose I am using sine A1. If I am using here sine A1, okay, this is A1, and when I will enter, there is no error. There is no error because all these are now symbolic variables. You can choose in many ways. Sine, I have sine, I have A1, then plus I have A2, then I have plus A3, then I have plus A10. Okay, so up to you can use, and you know all these are symbolic variables, and when I will enter, see, there is no error. So either you can use CLC and clear. Okay, CLC and clear. Now you can see there is no variable in the workspace. I am using this way also, since A1, A2, A3, A4, A5. Okay, and enter. You can see this statement also we are returning the symbolic variables, and you can use all these. You can use this also like sine A1. See, the same thing is there. So the meaning of the use of this statement is that by using this statement, you can generate numerous symbolic variables according to our need, our requirement, and we can use. Okay, so this statement is very small as compared to this one. Okay, if you need more than 20 symbolic variables, okay, so this will take just we need only this statement. See, there are now 20 symbolic variables are there in the workspace, you can see. Okay, but all these it is very hard to define by using sims function, like in this way. A1, then I have A2, and then I have A3, and so on. Okay, so this will take more time. The statement will be very large. So this is the importance of the use of this above statement together we can use to generate numerous symbolic variable. Whenever we need, we will do, and we will use this function also. Okay, so now there are only 5 symbolic variables, and statement is very quite simple. Professor Jyotsna, you got late today to join this session, and welcome in this session. Thank you to joining. Okay, now see here what we can do. The sims command is convenient shorthand for the sim syntax. Okay, in the place of this one, this function is very convenient because in the various type of functions or the programming, when we will use, we can declare the variable anywhere whenever it is required by using sims function. And it's a typical use to create a fresh symbolic variable for interactive symbolic workflow. The sim syntax to create the following: when we need a symbolic variable in MATLAB function, then we will use this one. And many numbered symbolic variable required, we can use this one. Okay, and also a symbolic variable whose value differ from its name in the MATLAB workspace, we can use. And this one is symbolic numbers such as A5, Sim5. Okay, this is the symbolic number only. We can use sim function, as you can see here. And also symbolic variable that inherits the assumption from the previously used symbolic variable having the same name. Then also we can use sim function. Sometimes if the variable is already used and we want to reuse the same, then we can use this function, sim function. Okay. Jacob Enamul, you are also joining today's session too late, and this session is very important to all of you because this is the part of symbolic mathematics, and in the beginning I have explained the importance of symbolic mathematics, but today's session is the foundation session for the coming because the symbolic tool is highly used for various type of problems like scientific computing, optimization techniques, differential equations, integrations, okay, mathematical modeling. Many problems are there. Without the use of a symbolic tool, it is very hard to simplify this type of problems. Okay, so here is some symbolic expressions. So all these symbolic expressions I would like to explain, and see here I have yes, suppose you want to symbolize the variable to represent the golden ratio. Okay, so this is the value for the golden ratio. Phi is equal to 1 plus square root 5 upon 2. So how we can store this information in the form of a symbolic variable? Okay, see here, this is the command. Phi is equal to, we have 1 plus square root, we need symbolic 5. Okay, we are using 5 as a symbolic. Okay, so this will not return the value in the form of floating. As you know, when you will take square root of 5, okay, when you will take square root of 5, this will return the value in the symbolic form. Okay, but sorry, this will return the value in the floating form, but we need the exact value. That's why we are using here symbolic number, and symbolic number is defined by using sim function. Okay, so when you will run this code, this will return the exact value as we have at this place. Okay, see in the MATLAB. So we are writing here, yes, I have phi is equal to, I am using here phi is equal to bracket, then 1 plus square root, sqrt is used for square root, but it is 5. Okay, then I need to divide it by 2. So when I will run this code, see what happen. The value of this expression I have is in the form of float. This is a floating value, but I need the exact value. That's why I have to use here sim. So now this number becomes symbolic number. Okay, and when I will run this code, you can see here this is the exact value as we are given. Also you can use here one more function that is pretty function I am using here, and that is phi. Okay, T. Yes. So this is the same as we have the exact, this is the square root by 2 plus 1 by 2 means this is the same as at this place in this equation. This one and the code you can see here, this value, both are same. Okay. So now this statement has been covered. If now you can perform various mathematical operations on this phi function. For example, if you have a polynomial of phi, as you can see here, f is equal to we have phi square minus phi minus 1. So this value will pass through this function at its place, and when you will run this code, the returning value will be in this form, and this is the exact value in the form of floating, sorry, in the form of symbolic form. Okay, otherwise if you are not using the symbolic number, then the value of this expression will be in the form of float. Okay, so you can see the difference here. I am using this statement now here. Yes, we are using the statement. We have at this place f is equal to phi square, then plus phi and plus 1. Okay. So when I will run this code, see the answer is in the form of symbolic, and this is the exact value, exact expression. And if you will use here pretty function, you can use also the pretty function for f. Okay, and when you will run this code, you can see the above expression in this form: square root of 5 upon 2, then we have square root 5 upon 2, okay, and plus I have 1 by 2, and its power is 1 by 2. You can see this whole expression has been converted in the form of pretty. Okay, if we are not using this sim at this place, what happened? You can see the difference. If you are not using pretty, okay, pretty not required at this place. Yes. I have, okay, just 1 minute. I have to remove this bracket also. Pretty is where? Okay, I have to remove this statement. Yes, now you can see when we remove sim from this place, now this number is not a symbolic number. That's why we have the returning value of this function in the form of floating. Okay, and if you will use here sim number by using in this way, and I hope you will see the difference. Yes, now we have this answer. So this answer is exact, and the previous one was approximate, because the floating value will never be the exact answer. So this is the use of this float for the numbers, and various ways are there to use. Here is how we can create symbolic expressions. We can do also create symbolic expressions. See here, we have the quadratic equation. Okay, f is equal to ax square plus bx plus c. So we need to write this symbolic expression. For that, we need to define all the variables which are involving at this place. So a, b, c and x are involving on the right hand side. First, we need to declare the symbolic variables, as you can see here at this place. Since ABC is equal ABC x. Here you need to always use at space space only. Okay, here is space. One step space is required. Then we can assign the expression to f by using this statement. Okay, so here is the meaning of this one is a product with x square. Okay, and this sign is used for exponent, and this will be written as b product x. Okay, and then we have plus c. If you are using only this one, okay, the meaning of this one is this is now one variable. Ax is now new variable in the Matlab. So the syntax is very important to understand how we can convert the given expression in the form of syntax of Matlab. This is very important to know. Okay, see in the Matlab expression. See in the Matlab expression. Yes. So what I am doing here, I am using here sims, then space x space a, b and c. These are required. Now these variables has been declared which are symbolic. Now I can use this symbolic variable for the quadratic equation. Okay, I have a x square plus I have bx plus I have c. So when I will run this code, yes, you can see there is no error. Okay, and you can see these variables in the workspace a, b, c, f. F is the function because the information on the right hand side stored in f. and x. Okay. If you are using here whose, you can see all the variables are in the command window. If the thing is, if you are not using here this sign, so this is not the right syntax for the quadratic equation, because now ax becomes one variable. This is a new variable now, which is not exist in the workspace. Ax not in the workspace. That's why this will return error. See, I'm running this code. Okay, and you can see in the command window there is now error. Ax is not defined a function or variable. Okay, so we have the variables a, b, c and x, and we have to use that as place this product sign. Sorry. Okay, so I have to use Control Z. Okay, now it is fine. And if you are using here pretty is also a function to present yes. Now you can see the expression is in this form, ax square plus bx plus c. That's why sometimes we can use pretty function also. Okay, now see this note very carefully. Okay, yes, the note is saying that to create a symbolic number, use sim in the command. Do not use a sims function to create symbolic expression that is constant. Okay, for constant we cannot use a sims function. Note this point very carefully. For example, if you want to create expression which is 5, so f is equal to, we have to use sim 5. Okay, and f is equal to 5. The command is f is equal to 5. Does not define f as a symbolic expression. So if you want to define symbolic expression, then we have to use this one. And if you are using f is equal to 5, this is the only assignment. The value 5 is assigned to the variable f. Okay, and this will not be the symbolic expression. You can see here in the Matlab, see in Matlab. Okay, so when you are using Matlab and do the experiment, this will always very helpful to all of you. Okay, thank you. Vani asking about the pretty function. Pretty is not just to convert the expression in the pretty form. As you can see, if I am not using the pretty, okay, if I am not using the pretty function, as you can see, and when I will run this code, so see, f will appear in this way. If you are using here pretty, if you are using here pretty function for f, then this pretty function what will do, this will convert in this form. You can see the difference between these two. This is in the form of a MATLAB syntax, and this is the exact what we have the quadratic equation. Okay, only this is the meaning of pretty. This expression is converted into this form. This is the syntax of the MATLAB. and this is not the syntax of the MATLAB. Okay, so pretty function will convert exactly as same we have the mathematical expression. So this is the use of pretty function. Okay, now CLC, yes. Here you can see reuse name of a symbolic object, and this is also possible in the MATLAB. Here you can see, uh, if you set the variable equal to the symbolic expression and apply the sims command to the variable, MATLAB removes the previous defined expression from the variable. For example, you can see here, we are see this expression. We are using here two symbolic variables a, b, and f is equal to, we have a plus b. So when you will enter, this will return this value. Note this point very carefully. When you will enter this statement in the command window, this will return this value. Okay. Later, if you are using f as a function, you are using this statement sims f. So when you will enter f, this will return f equal to f. So now at this place, this variable has been replaced in the new format. Okay, see in the MATLAB if it is required. Okay, it will clear more concept. See in the MATLAB, what I am doing here, this is sims, and sims is a and b. I enter, then f is equal to, I have a plus b. Okay, and when I will enter, this is returning f is equal to a plus b. If again I am defining by using sims function f, now what is there? F is now symbolic variable. Okay, so the thing is, previously it was f is equal to a plus b, but now when I will enter f, okay, f is equal to, I have f. If I am using sign f, okay, so the meaning is that now f is a symbolic variable, which is a new one. See once again, if I have g is equal to a plus b plus ab, okay. So when I will enter g, you can see a plus b plus ab. But if I am using sims g, now what happened? G is now symbolic variable when I will enter. So the previously the g information in g has been removed. See, when I will enter, this will not return this value. This will not return this value. This will return j is equal to, I have something. Okay. Sorry. Yes, j is something. So this is the use of this was new statement, so this information was printed at its place. Okay, so see once again, when I will enter here g, the previous variable has been removed. Okay, j is equal to g means g is now symbolic variable. I think you got it. If you have any question, please let me know, or I will be very happy to see your questions in the chat box. Yes. So also we can create a symbolic variable, a symbolic function. Previously we discussed about the symbolic function. Okay, but now we are talking about the Previously we discussed about the symbolic variable, but now we are going to discuss about the symbolic function. So by using the same, we can easily declare the, we can create symbolic function also. See here, symbolic function represent the math functions. We use symbolic functions for differentiation, we can use for integration, we can use for solving ODE and other mathematical operations. And to create a symbolic function, we are using sims. Sims will be used to define the symbolic function. Okay, so to create a symbolic function f with variable x and y, we are using here sims, and create f automatically x and y. So this is the syntax. Sims f is a function of x and y. Okay, and then you can write any function involving these two. You can see here fxy is equal to x square product y. When you will enter this statement, this will return this value. Fxy is equal to x square plus y, x square product y. Okay. Also, you can pass the values through this expression. So previously, the way of using was not the correct because we need the symbolic function, only then we can pass the values. In the beginning, we were facing the prompt to pass this value. Okay, so first we need to define symbolic function, and only then we can pass the value. As you can see here, when you have x is equal to 3 and y is equal to 2, the value of this expression will be 13. See in the Matlab how we can do all this type of defining the symbolic function. So we can choose any example. Okay, so yes, so here I am using sims f comma xy, x comma y, and I have fxy x comma y is equal to, we have x square product y. So press the statement. Okay, so when I will run this code, you can see in the command window there is no error. Okay, so if I want to pass this value 3,2, now this is the returning value. I want to store this value in numeric value. I want to store this information in this variable. Okay, numeric variable. So the information will be stored in this one expression. Yes, or this is enough. Yes, you can see when I will enter here nm, the value is 18. The value is 18. Okay, if you have x is equal to, I have 1, 2, 3 and 4, and y is equal to, I have 2, 4, 6 and 8. fxy. We are checking this will work or not. Okay, so when I will run this code, you can see the x and y length of these two arrays we have equal 1 and 2. So when we will have x is equal to 1, y is equal to, we have this value. X equal to 2, y is equal to 4, we have this value, and so on. So this will take element by element and returning the answer at its place. Okay, so in this way we can use this function, and we can pass numerous values by creating this type of function. Okay, see some more interesting questions if there are related. Okay, this is not the end till now. Yes. So CLC, we can differentiate this function also with respect to x and y. I am presenting here some few examples also, so that this will help you in the coming session. See, I have f xy is equal to x square product y. Dfx. Okay, we want to differentiate f with respect to x. Okay, so this is the notation only. And how we can do? I am using here diff function is inbuilt function in the MATLAB. Okay, and here I want to differentiate f with respect to x. This is the derivative, partial derivative of f with respect to x. Okay, and when I will run this file, you can see this is the answer. The derivative of this expression we have is 2xy. Okay, if we want to calculate, diff xy, x comma y, okay, 8x equal to y plus 1. Okay, we can do. How we can do? This is very quite simple. Just what we have to do, we have this is the derivative and we need to pass the value. See, diff x, and what I will do, I will put the value at the place of x, which is y plus 1. Okay, then I have y. We need to put only x is equal to y. So the function dfx is a function of x comma y. Okay, so we are just need to put this value at the place of x. Okay, so when I will run this code, this will return this answer. Okay, and you can see now x is absent in this expression. X has been eliminated by using this value. Okay, and if you need second order derivative. Suppose I want to differentiate with respect to y. So this is the partial derivative with respect to x and with respect to y. See, okay, I have to remove this one semicolon. You can see this is the partial derivative of this expression. We are extending this one. We want to extend this one. I am using here sine x square plus y square. Okay. So when I am using here, this is the mixed partial derivative of f with respect to x and y. So this is the corresponding answer. If you need second order partial derivative with respect to x, so this will return second order partial derivative with respect to x. If you need, you can use also 2 at this place. We have the same answer. If you need higher order, suppose I need 4th order, then you need to use at this place 4. So you can see this is the 4th order partial derivative of f with respect to x. If you need with respect to y and with respect to x, we need second order, and with respect to y also we need second order. You can use in this way. So the meaning of this one is this is the 4th order partial derivative with respect to x second order and with respect to y second order, and the total is 4th order partial derivative with respect to x and y. See, Matlab becomes busy. I think there is some error. Okay. It is saying that there is some error. Diff calls with 2 or 3 argument. Okay. It's saying that this one will take only 2 or 3. So in Python we can do this type of operation, but in the MATLAB this is not possible. It will take only 2 or 3 argument. Okay, diff function. So only for one variable of higher order we can do. If you need this type of order, then you can use in this way. Suppose I need 4th order with respect to x, then 5th order with respect to y. So what I will do? I have the solution. In the MATLAB, we can do in this way. See carefully. This is very interesting part here. So in this part, which is in the parentheses, this will return the partial derivative of f with respect to second order. But still we want to differentiate with respect to y for any order, say third order. Y with respect to y, and order is 3. Now it is fine. Yes, we have the answer. Great. You can see in this way we can have the partial derivative. So the meaning of this expression is we have the total order is 5. So this is curl 5f upon curl x square and curl y cube. So the meaning of this expression we have is this one. Okay. So dear, if you have any question, you can put in the chat box. any question? You are not putting any question. I am surprising to see that from your side there is no question. Okay. So I think this concept is very clear. So what do we do in the coming session? Today we finish now. Okay. In the coming session, what we are going to do? In the coming session, we will discuss about differentiation, integration, limits, differential equations. So all these things we will cover by using this symbolic tool, and this will help you to understand how we can do this type of operations. Also, we can do double and triple integration with their upper limit, lower limit, and also we will do some operations involving when the limits are not constant. Okay, many things are there, just we need to understand or check the syntax in the MATLAB. Okay, so thank you very much to see this lecture till the end, and we will join the meeting in the coming Sunday at the same time. If you have any question related to this, you can comment in the chat box, and your comment will always motivate, and this is very motivation for me. So thank you very much to see this lecture till the end.